coding chunk up here, and then I asked it in here to do some stuff with fish. The value of fish would change accordingly with whatever you've run beforehand. So first of all, let's have a go at accessing the data we've got in the question. So this is section 1a. Let's put a little bit of text at the top outside of our coding chunk, simply to say that this is answer to 1a. Now let's access our data. So we're going to define a new object called data, because we're being simple and no need to confuse ourselves. And we're going to read in this RDS object. Now, because you're using R Markdown, it should be the case that as long as you save your R Markdown file in the same place in which you've downloaded and stored the RDS files, it should immediately recognize where they are. As it happens, I've saved my RDS files in the same folder as this document, which means I can immediately access it. How am I doing this? Well, I want to use a function regardless of where it's saved. I type in read RDS and I do open brackets, and I want to say my file is, we use these quotation marks, maybe even 2 if it's clearer. And I'm in my desktop and I'm looking for Q1A data RDS. Wonderful. So data is going to, well, this Q1A underscore data dot RDS is going to be read through this function into the object of data. Wonderful. Now I can immediately look at my data here. Whoa, look at all this. Isn't this exciting? So we have a lot of data points, and we have some missing data. We've got age in years, mass in grams, call frequency in hertz, and the humorous length. Lovely. So now what are we going to do? Well, let's look at the first question. The first question says, you receive survey data of a wild ecological community. One species catches your eye. Okay, so we're going to look at this adult data found in question 1a, data.rds, which we've just read in. Compare variables from the survey data and identify the most interesting relationships. Plotting your findings, justify your answer from an ecological perspective. Okay, so let's have a look at some variables. How do we start to answer this question? Compare variables from the survey data and identify the most interesting relationship or relationships. So we've got our data, and we can see it's made up of what's a simple sort of data frame. We have columns and we have rows. How do I start to tell R to look at certain types of data? If I wanted to read in the first row and the first column, where they intersect, we find this square. I want to read in this value. What do? I simply say first row, first column, data 1, 1 with square brackets, and I hold down Command or Control Enter to quickly run this line, and I get 5. That's the value we found here. Wonderful. What if I want to, shall we say, look at an entire column? Well, that's easy, because I can simply leave an empty space on the row and say I want to look at the entire of the first column. So it's just saying just the first column, but I'm not specifying any rows, so give me all of them. Command or Control Enter, depending on your computer. And here we are. Now it's got me the whole list of all the ages of the first of this data set. Lovely. I could have also simply have done $ and age years. If you're going to be using that, make sure you get these backtick quotes. And I press Command Enter. There we go. Lovely. So these are interchangeable. Remember that if I assign value to a component, if I said data 1, 1 is now 7. And we go back to our data. Oh no, I've changed the data. You don't want to do that. You can feel free to take out data and create a new data set and then manipulate that to investigate whatever you'd like. However, we don't want to do this to our base data. We want to keep that as a useful source. So I'm going to correct this by rewriting the data with the original file, and therefore we shall see that we are back to a value of 5. Okay, and let's plot a simple relationship. We're going to use base R. I've included a variety of plotting opportunities for you to access and investigate and play with yourself if you look at the introductory document alongside this. Here I'm simply going to plot using the base R plotting, shall we say data $, let's look at mass, comma, and now we're looking at the other variable, which will be another column. Here we're going to look at humerus length. So now we have mass versus length of a body part, and I simply need to, well, I can choose to run this as a play or as an editor. Now, of course, we run the first component, which is data 1, which is 5, but this is way cooler because now we can see that there is, oh, that's interesting. There's some sort of relationship between an individual's mass and the length of their humerus. So we have survey data showing the relationship between different components, different metrics of an individual, and we take tons of individuals and now we have a lovely plot. It's up to you to have a look at these relationships and try and figure out what's the most interesting. What is, shall we say, the most irrefutable, or the most personally interesting, or the most exciting relationship you can find, and try and think along the lines of what grabs my attention. Is there anything I can do to prove this is, or at least anything I can do to statistically demonstrate this is the most important relationship, etc. And that's up to you. So from here, I will simply wish you good luck. And if you have any questions, if you're trying to understand if there's anything you've missed, or if you have any concerns over the format or how to deal with debugging issues where your code goes wrong but you're not quite sure why, I'd strongly encourage you to follow the theme of this project, which is using ChatGPT, Google AI, etc. to support your coding work, giving you advice, etc., as well as Stack Overflow and the variety of online forums which have existed long before any of this new AI came out. Thank you very much, and good luck. I hope you enjoy it.